So, good evening, all of you. Hope you are enjoying learning, growing, catching up the speed now. We'll wait for 2 more minutes and then we'll. Today we'll be doing practice sums of squares and square roots. I'm sure you must have tried all the questions that we did in lecture 7 and then these questions of lecture 8. Now we will be taking into account our understanding of ratio proportions, our understanding of prime composite numbers, our understanding of all those topics which we have done till now. And we will use that in questions based on squares and square roots. Okay. We will finish in 1 hour today, most probably. At the most, 5 minutes more we'll take. And now you can start picking up questions from elsewhere also on these topics. You may be having some books already if you are appearing for some other competitive exams. You may be having books for that already, or you can just go to the market and take any book and keep practicing irrespective of whether you appear for our entrance test or no, anything. But if you have given these sincere 12 hours, use those 12 hours to bring some definite growth in you. Like after this course, don't just leave away. Ki ho gaya, 12 lecture ho gaya, bas band karke rakh diya. Now you have learned. So basically what we want is you start thinking on yourself. Take any problem, think on multiple solutions, think on some good ideas, some tricks of yours. Keep on the process. Okay. Those who are in 6th also, next year you can keep the process on. If you appear for our entrance test, then some of you may get selected also for our foundation program. Otherwise also you can keep up your growth. Don't have come in a good gear. Okay, it's 7 o'clock, so we'll start now. See the first question. 3 numbers are in the ratio 3:4:5. If their sum is 48, find the square of the middle number. So now we know in ratio proportion, if the ratio of the numbers is 3:4:5, we can consider the numbers to be 3x, 4x, and 5x, where x is the constant of proportion. And therefore, their sum will be 3x plus 4x plus 5x. That will be 12x. Okay. So if their sum is 12x, and that 12x is equal to 48. If 12x is 48, we know that x is equal to 4. X is equal to 4. And if x is equal to 4, what will be the numbers? 3 multiplied by 4 will be 12. 4 multiplied by 4 will be 16. And 5 multiplied by 4 will be 20. So the numbers are 12, 16, and 20. And what are they asking? The square of the middle number. So the middle number is 16, and square
एक मिनट आई तुझा ऑडिओ येत नाहीये. Can you hear me, everybody? Okay, just give me 1 minute. I'll check with madam.
and then if you will know the table of 13, 13 tens are 130 plus 11 will give 143. Your brain should run very fast. Quick. Okay, you should keep finding the track and how to reach to the answer fast. For that, you need to read the question carefully. Use your toolbox very wisely. Whatever you know, you have the whole toolbox with you. उसमें से अभी क्या निकालना है? हथौड़ा निकालना है, छन्नी निकालनी है, पकड़ निकालनी है, खिला निकालना है, कैंची निकालनी है, क्या निकालना है, वो समझ में आना चाहिए. नहीं तो टूल बॉक्स भरा पड़ा है. अरे हम लोगों को पता ही नहीं. अरे अभी हथौड़ा ले ले कि ये ले ले कि वो ले ले, इसमें से क्या लेना है? Then there is no use of toolbox. If you have the toolbox, you must know which tool to use at what time. So both things are necessary. You should have a rich toolbox, and then you must know which instrument I'm using just now to reach to the answer confidently and fast. Okay, so the answer over here is the numbers are 11 and 30. We have used multiple logics to come to this answer, and they want the smaller number, so our answer is 11. All right, next question. Under root of 121 upon 169 plus x is 14 upon 30. Now, as I said, if you know the squares up to 20, the story becomes really simple. So 121 is the square of 11. So square root of 121 will be 169, and the square root of 169 will be 30. So if you know squares, you will know that under root of 121 upon 169 is 11 upon 30. Now see over here, don't try to cancel this out inside. When you see these as complete squares, if these were not complete squares, then maybe we need some cancellation within. If these are not complete squares, then maybe we need the cancellation within. And then we will come to some number for which we can find the square. But here, coincidentally, I can see that 121 is also a square and 169 is also a square. So we have learned that square root of division is like square roots of their what you will say. In division, the square root of the rational number, the fraction is the square root of the individual numbers. So I can definitely say that square root of 121 upon 169 is 11 upon 13. And then 11 upon 13 plus x is 14 upon 13. So to find the value of x, I will simply shift 11 upon 13 on the right hand side. I will shift 11 upon 13 on right hand side. And now I'm not going to make it ulta because it is plus this whole fraction. I will keep the whole fraction as it is and plus will become minus. Please remember here, I'm not making it upside down because it is not multiplication. If it was multiplication, then I would have written this as 13 upon 11. Many children will do this mistake. By taking it on this side, they will write it as 13 upon 11, cancel 13, 13 and bring the answer as 14 upon 11. That is wrong. Here it is plus here and I'm transferring it to the right side as it is. I keep it and make it minus. Now by our fraction subtraction rule, if the denominators are same, we will simply subtract the numerator. So 14 minus 13 minus 14 upon 13 minus 11 upon 13 will be 3 upon 13. That will be my answer. So first you must know the square roots and then you should not mistake this and make it upside down on getting it on the right hand side. Okay, these two hurdles you have in this question. So the apparently easy looking question also needed two good pieces of thinking. That is why I have included this question. Next question. Find the value of 1296 upon 36. Okay. Now we have two ways of doing this. We can find under root of 1296 separately. Then we can find under root of 36 and then do the division. Now find 1296 root by approximation method that we did the other day. This is falling between 30 square 900 and 40 square 1600, correct? So this is the square of 34 or 36. Because it is ending with 6, I know that the square root should end with 4 or 6. So this is the square of 34 or 36. But I know 35 square is 5 5s are 25 and 3 4s are 12. 35 square is 1225 and 1296 is greater than that. Therefore, 1296 is the square of 36. So this will be 36 upon square root of 36 is 6. Cancel. Answer is 6. This is first method. We found the square roots of both the numbers separately and then did the division. Method 2, do this division first. Divide 1296 and 36. Let us see what we get. Okay. I can see that I can divide this by 6 because 6 2s are 12, 16 6 are 96. Very quickly I can compute that this is divisible by 6. So 6 6 are 36, 6 2s are 12, 6 1s are 6, and again 6 6 are 36. Again 6 1s are 6, 6 3s are 18, and 6 6 are 36. So 1296 upon 36 is 36. So this is equal to root of 36, which is 6. So both the methods, whichever method is suitable for you, you can go by that. All right, answer will be 6. We are using the rule over here that in division, the square root of the numerator divided by the square root of denominator is equal to the square root of the fraction. Okay, that rule. Then the next one, 112 upon root of 196 into root of 576 upon 12 into root of 256 upon 8. Now once again, if I know the square roots, 196 is the square of 14. So 112 upon 14 multiplied by 576 is the square of 16. So 16 upon 12 multiplied by, sorry, yeah. 576 is the square of 24. Very sorry. 576 is the square of 24 upon 12, and 256 is the square of 16 upon 8. So if I know the squares up to 30, my story becomes very simple and it goes very, very fast. Now, because all this is in multiplication, I can quickly cancel 8 ones are 8 twos are 12 ones are 12 twos are, and those who know the table of 14 or 7, if you don't know 14, then 7. 7 twos are 7 ones are 7 6 are. Then again 2 gets cancelled and you get 16 twos are 32. 32 will be the answer. Okay. If you want to find 14, 7, how many are 1, 1, 2? Then a quick method is, it will end with 8, no? Ending with 2. And 10 8s are 80. And 14 is 4 ahead of that. So 80 plus 32. Horizontal table will give me 1, 1. Okay, but the answer is 32. So all these tricks and pranks, keep doing them as a practice. Maybe you know the table of 14 and you know 14 8s are 1.2, but then use horizontal tables so you develop a hand over it. You develop an expertise in it, and you will be able to use horizontal tables more efficiently in more difficult questions when you practice with simple questions. Always practice with simple questions to strengthen your capacity to use a particular trick. Okay, next question. 64 upon 56 is root of 64 upon what? Now, many of you might have written it as 56, but that is not the thing. What is 64 upon 56? When I reduce it to the lowest fraction, I know it is, if I divide both numerator and denominator by 8, 64 divided by 8 is 8 and 56 divided by 8 is 7. 8 8s are 64 and 8 7s are 56. So 8 is the, you can say, the common factor by which I'm bringing it down to the lowest form. And now 8 upon 7 is under root of 8 is under root of 64. And what is 7? It is under root of 49. So under root of 64 upon 49 will be 8 upon 7, which is equal to 64 upon 56. That is one way of doing it. Another way of doing it is 64 upon 56 is under root of 64 square upon 56 square. It will come to the same. So again, you'll have to bring this down to 8 upon 7 only, and it will come to 64 upon 49. Okay, so this was fastest. Next question. Find the difference between under root of 25 plus 144. Now here is what we have learned for squares and square roots, that square of a plus square of b is not equal to square of a plus b. Square root of a plus square root of b is not equal to square root of a plus b. This is what we are going to demonstrate. So what is square root of 25 plus 144? 144 plus 25 gives me 169. And square root of 169 is 30. And if I do it separate, square root of 25 is 5, square root of 144 is 12, and sum of that is 17. So once again, we have demonstrated that square root of a plus square root of b is not equal to square root of a plus b. And what are they asking? The difference in these two values. Again, once again, I'll bring your attention to what is asked over here. They are not asking 13. They are not asking 17. They are not asking 169, 5, 12. They are asking the difference in these two values. So our answer is 4. If it is an MCQ or if it is a 0099 type exam, we will just look at 4. So be very careful about what is asked and enter what is asked. And I had asked you to find out if you can find the missing factor over here. Why this is not equal to this, and what do I need to add to this to get this is your research question. I hope you have started thinking on it. Think a lot. Don't give up. The more you think, the more your brain cells grow. Actually, this is a physiologically proven fact that the more you use your nerve cells, the more they will grow. And in early ages of life, this growth is so much more concrete. So in this particular age, up to 12, 13, whatever brain cells you will grow, they will stay open, and then you can keep filling in it. So tease your brain as much as you can. In this age, keep teasing your brain, keep asking questions, keep nagging yourself. That is why such questions are called as brain teasers. They will actually poke your brain, and in that it will bloom. Okay, this is an absolutely physiologically proven fact. Okay, next question. Square root of a number is 1/5 of the number. Forgotten the full stop. I will put it and send it to you. Square root of a number is 1/5 of the number. Find the number. Okay, now I don't know the number. My method 1 is, let the number be x. Then the square root of the number, that is root x, is 1/5 of the number, meaning root x is 1/5 of x. That is, can I say x upon 5? Square root of a number is 1/5 of a number. So root x, what is the equation that I'm getting? Root x is equal to x upon 5. Then I want to find the value of x. So what I need to do? I can get the x on this side and I can push the 5 on this side. Now 5 is in denominator, so it will come in numerator. X is in numerator. What is root x? It is root x upon 1. So root x is in numerator, it will come in denominator. So I can say that 5 is equal to x upon root x. Now what to do over here? Can I write x as root x into root x? I can write x as root x into root x. Root x square is x, no? So root x into root x upon root x. And again, everything is in multiplication division. So I can cancel 1 root x to root x. So what do I get? I get root of x as 5. And if root of x is 5, what will x be? X is square of this, no? So x will be 25. Once again, let my number be x. Root of x is 1/5 of it. So I know root x is equal to x upon 5. So I get x upon root x as 5. I express x as root x into root x upon root x. So 1 root x gets cancelled. So I get root x is equal to 5 and therefore x is square of root x. If I'm squaring the left hand side, I will have to square on the right hand side also. So x becomes 25. This is my method 1. I started with x. Now my method 2. I'm little smarter. I want to find the square root of the number. So can I consider the number as x square? Let the number be x square and then its square root will be x. And if x is x square upon 5, I will directly get 5 is equal to x square upon x. That is x. And now what is my number? Square of x. So x will come 5. I don't have to do that root x cancelling. But for that, I need this initial smartness that instead of considering the number as x, मैंने number को x square पकड़ लिया तो उसका root x हो गया ना. So my calculation became easy. Instead of cancelling that root x, this became much more easy. Then I got x is equal to 5, but now my number is x square. So my answer will be 25 in any case because I had considered my number to be x square. This is my method 2, little more smart. And the third method now, still more smart. If we understand the meaning of square root, suppose a is my number and its square root is root a. So what is my number? Root a into root a. Understood? This is my number and this is its root. So when I multiply the root by itself, I get the number. So if my number upon its root is 5, meaning 2 times 5 is my number, then only I divide it by itself, the square root, I get that number, no? Are you getting? Little abstract logic. When I divide the number by its square root, I will that which comes in the denominator. So if it is 1/5, that means the number is 5 times of 5. Then when I divide it by 5, that is the square root, I will get the number. Little abstract logic, पर जिसका दिमाग चलेगा ना, उसका रॉकेट उड़ेगा एकदम. You must learn to think, create such abstract, quick ideas and land on the answers very fast. Okay. So 3 ways we could have done this problem, and such abstract ideas, they will grow your thinking capacity that is needed for competitive exams like IIT or any other competitive exams which you are looking forward to. You will need such abstract thinking and speedy ideas which are vague logics, but they are absolutely correct. Next question. I'm just giving you glimpses of such abstract logics. Now it is up to you how much you would want to develop that aspect of your thinking. And for that, you will need to sit with the subject for a long time. You cannot just do away with the questions and learn these things. You have to settle, enjoy, keep thinking, keep things going on in the back burner on some question. If you've not got the question, keep it burning in your mind somewhere. You can always keep working on it on your mental board, keep thinking over it. If something comes to your mind, quickly write on the notebook. Constantly keep thinking, and then you will have some very good development in your thinking patterns. You ही नहीं निकलते toppers in the nations, international Olympiad medalists. They don't come just like that. It is the sweet fruit of perseverance. Go on thinking, go on thinking, go on doing, then you get it. Okay, the two consecutive numbers between 150 lines. Now I have to think of two square numbers around 150. The closest smaller square number to 150 I can see is 144. So root 150 lies between root 144, which is square of 12, and the next square number to 150 I can see is 169, which is the square of 13. So root 150 lies between 144 and 169. So root of 144, root of 150 will lie between root of 144, that is 12, and root of 169, that is 13. And it will, so root of 150 will be 12 point something something. So 150 is not a perfect square. 144 is a perfect square of 12, 169 is a perfect square of 13, and 150 is a square of some number between 12 and 13. So 12 integer something upon something multiplied by 12 integer something upon something will give me 150. But this is not a natural number, and therefore 150 is not a perfect square. But our answer will be that root 150 will lie between 12 and 30. Okay. So wherever possible, I'm trying to revise the words that we have discussed in the last lecture. Then root of 176. Now see how this question is written. It is under root of 176. Don't raise your hands and all that. You know, in this format, we are not letting you talk anything. So why you want to raise your hands, put something on the chat? Okay. This is a one-sided lecture series. And as promised, those who will be with us in future, we will have smaller batches and interactive sessions where we will definitely interact with the students live in the sessions. or we will keep separate doubt sessions. But this is a very special series. So here it is all one-sided. And therefore, to make it simpler and simpler, we are posting the YouTube videos for you to see again and again, posting the printouts, posting the answer keys, everything. But don't unnecessarily raise hand or something, no? Because you're not going to get a chance to talk. Then why are you raising hand? At the most, you can show a thumb if you like something. Okay. Now this is a under root, under root, double under root. Notice this. So just like BODMAS, I will have to first solve this. I will have to find what is square root of 2401. Now once again, we can do the square root of 2401 by factorization or by approximation. Both ways we can do the square root of 2401. I want you to do it by both the methods after the lecture today. Just now, I'm quickly doing it by approximation method. 2401 lies between 40 square 1600 and 50 square 2500, and it is ending with 1. So my square roots will end with 1 or 9. So there will be 41 or 49. And I can see that 2401 is very close to 50 square. So I take it as 49 square. I want you to confirm it in 3 ways. First, do factorization method. Second, find 49 square by our shortcut technique, just as practice, and confirm that 2401 is 49 square. So now how I'm going to write this? This becomes under root of 176 plus. Now root of 2401 is 49. So I have removed this under root sign now, and therefore I can write it as 49. Now what is 176 plus 49? I will get it as 225. 176 plus 49 is root of 225, and I know root of 225 is 15. So my answer is 15. So what was the middle step? I first had to find the value of root 2401 and then again put it in root sign, then add this, and then find the square root of this. And this is not going to be equal to root of 176 plus root of 49. Try it. It will not come as it is, because root 176 is not a perfect square as it is. So root 176 plus root 49 will come 7 plus some rational number which can never be 15. So keep cross-checking all the rules that we have learned. Our final answer will be 50. All right. Next question. Simplify. So this is now again BODMAS, fractions and square root, 3 concepts together. Remember, as you go ahead, you will always have questions on multiple concepts in one question. So here now, forget about the root sign. Let me first find the value of this whole thing that is written in the root sign. Okay. So it is 8 upon 15 plus 15 upon 8 divided by 5 by 6. So abiding by my BODMAS rule, I will have to first solve the bracket. When I have to solve the bracket, I will go by the LCM method, addition of fractions. The denominator is a product of 15 and 8, that is 120. For the numerator, I will cross multiply and add 8 8s are 64 plus 15 15s are 225. So 225 plus 64 upon 120. will be the value of this bracket divided by 5/6. Okay. Now what is 2? Now again, this bracket is still not complete. I cannot cancel this 6 to this 64. Plus it is division. Too many steps in between. You can go wrong in any step. I still need to simplify this. 220 plus 64 is 289. So it is 289 upon 120 divided by 5/6. And now what I know about division of fractions? Division of fraction is the multiplication of its reciprocal. So I will further need to modify this and rewrite it as 289 upon 120 multiplied by 6/5. See here, we have still not reached the square root thing. We are still in solving the expression only. First, we opened the bracket, then we converted division into multiplication. Now, since all of this is in the multiplication division form, I can cancel things. So 6 ones are and 6 twos are. I will get. So now I get it as 289 upon 20 into 5. Now I can see that 289 is neither divisible by 5 nor it is divisible by 20. So I keep it like this only and I get it as 289 upon 25 is 100. And now this whole thing is under the square root. Now I've got the value of this whole expression. So this is same as 289 upon 100. And now I know 289 is 17 square and 100 is 10 square. So this becomes 17 upon 10. It was a long sum and many steps that checked your understanding of fractional addition, BODMAS, fractional division, and understanding of square roots. 4 concepts were checked in this question. Now this I can write as 1 integer 7 upon 10 or 17 upon 10, or those who know decimals, we can write this as 1.7. Another way of doing this is 289 upon 100 is under root of 2.89. Those who know decimal division, 289 upon 100 is under root of 2.89 and square root of 2.89 is 1.7. Direct answer. So many ways of approaching a question. Do every question many times in different ways. Then the next question. Root of x is 135 minus root of 100 upon 25. Okay. So this is 135. I know root of 100 is 10 upon 25. So 135 minus 10 is what? 125. So 125 upon 25. That is 5. But what is 5? 5 is root of x. So what will x be? Square of this and then square of this. So x is 25. Okay, see what we did? We have simply found a numerical value of this, which is equal to root x, and therefore to find x, we just squared up both the sides and the answer came 25. Okay. Next question. I have purposely kept more questions in this exercise because you need a lot of practice. That is one thing. And secondly, I thought we can squeeze so many questions in 1 hour. So I have kept 15 questions for this set. Okay. Which is the smallest number with which 1200 should be multiplied so that the product obtained will be an even number and square. We saw the method. We will have to prime factorize 1200. We know that the factors of a square number are always in pairs. I will need a pair for every factor, and then the unpaired factor can be paired. So if I go for 1200, I will see that it is 4 into 300. That is 4 into 4. Again, 300 can be divisible by 4. And then into 75. So I got a pair for 4. Then it will be 75 will be 5 into 5, 25 into 3. So I got a pair of 5 also. So what are the final factors of 1200? 4 into 4, pair of 4, into 5 into 5, pair of 5, and this 3 is unpaired now. So if I multiply 1200 by 3, I will get a number in whose factor I will have a pair for 3 also. Obviously, what will add in the factor of 3600? I have multiplied the main number by 3. So by factor also there will be 1, 3. And then I will get a pair of 4, pair of 5 and pair of 3. And then this will become a perfect square. And this is the smallest number with which I can multiply 1200 to get a square number. What have I done? I have factorized 1200 and removed pairs and located the unpaired factor. And when I multiply the number by the unpaired factor, I will get the closest square number to 400 to 1200. And even if I divide 1200 by 3, that means what I am doing? I am removing this unpaired factor. If I divide 1200 by 3, I am removing this unpaired factor, then I will get 400, which is also a square number, because now in 400, there will be one pair of 4 and one pair of 5. So a non-square number can be multiplied by the unpaired factor to get the higher closest square number, or it can be divided by the unpaired factor to get the lower closest square number, and we can convert a non-square number to a square. Understood? So our answer over here will be 3. Next question. 1 is subtracted from the square root of 4 times a number. 1 is subtracted from the square root of 4 times a number. The square of the answer obtained above is 40. Okay. So let my number be x. I want 4 times the number. That will be 4x. And square root of 4 times a number. That will be square root of 4x. See, I'm just following the instructions. I'm subtracting 1 from the square root of 4 times of a number. So this is my number. This is 4 times. This is its square root minus 1. 1 is subtracted. Whatever answer I get obtained above, the square of the answer is 49. Understand this. So what is my answer? 7. Please understand the wording. Don't take 4x root 4x minus 1 as 49. The square of the answer obtained. So root 4x minus 1 is square root of 49. That is 7. So how do I go? So root 4x is, if I take this one on this side, I will get 7 plus 1, 8. And if root of 4x is 8, what will be 4x? Square of 8, no? I will square both the sides. When I square this root of 4x, I will get 4x. When I square 8, I will get 64. So 4x is 64. What will be x? 64 upon 16. So 64 upon 4, that is 16. See how I have navigated? 1 subtracted from the square root of 4x of a number is the square root of 49. So how I have converted? This is called as converting a verbal information into a mathematical expression. This whole bhashan I have converted into a mathematical expression by carefully reading what the information is given. And then I am solving. From here starts maths. Till here, unless you have a good understanding of language and how to write something mathematically, that is very important. Then root of 4x is 8, so 4x will be 64, x is 16. Let us tally square root of 4 times of the number. If the number is 60, then square root of 4 times, that is 64, minus 1. What is square root of 64? 8. Minus 1, 7. Is this the square root of 49? Yes. My answer is that. Okay. So this is an art to convert a verbal information into a mathematical expression. That is why many children are very bad in doing word problems, because they are unable to convert a verbal information into mathematical expression. That is also part of your practice. Now 5 upon root x is 25. So what can I say? 5 upon root of x is 25. Then I can take this over here and this over here. So 5 upon 25 will be root of x. What is 5 upon 25? 1 upon 5. If root of x is 1 upon 5, what will be x? Simply square of this. If root of x is 1 upon 5, then x will be 1 upon 25. 1 square is 1, 5 square is 25. And what are they asking? They are asking x square. So I'll have to again square on this. So 1 square will remain 1 and 25 square will become 625. So the final answer is 1 upon 625. Okay. So root x is 1 upon 5, x is 1 upon 25, and x square will be 1 upon 625. These were the problems for Today we have correctly finished in 1 hour. So, as already discussed with you last time, I may not send the solutions immediately. I may send it late night today or maybe tomorrow morning. So I would want you to once again check over whatever answers you got right by different method, whatever answers you got wrong, check out on the method given over here and redo the questions. Okay, and on Saturday we will start with a fresh topic. We've already done with 4 topics, 2 more topics to go to finish the series, and then we may begin with a completely new relation with you, those of you who would appear for our entrance and they get selected for our foundation program. You will have